Hello students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting and a very relatable topic, that is algebraic expressions. Now in this chapter we will learn about what is constant, coefficient, powers, their introduction, types and degree of algebraic expressions, addition, subtraction of algebraic expressions. Now let's start with the introduction. Now what we know that expressions are our what? Expressions are our central tendency. In this chapter we will study about our algebraic expressions and we will know how algebraic expressions are formed, how they are combined and how we can find the value and expression. Now here's our example. Here we have to find the cost of notebook is this. 2 notebook will cost 60, 3 will cost 30 and so on. So here are the notebook and here are their cost. So now we can easily find out the cost of 10 notebooks also. So observe this pattern. For 1 notebook 30 into 1, for 2 30 into 2 and so on up to for 10 it's 30 into 10. So that means for X notebook the cost will be rupees 30x. So cost of X notebook is 30x. That means it is our generalization of how we can find the cost of any number of notebooks. Whatever may be the number of notebooks, we will substitute X with the number for which we get the value. Now here is our figures from 1 to 5. And in these figures, let the number of trapeziums be X and the number of matchsticks be Y. Now number of trapeziums is 1, 2, 3, 4, 5 keeps on increasing and number of matchsticks is 5, 9, 13 and so on. So observe the table and you will find a pattern, and the pattern here is in 1 trapezium number of matchsticks is 5 into 1 minus 0, in 2 trapezium 5 into 2 minus 1, in 3 trapezium 5 into 3 minus 2, and similarly for X trapezium it is 5 into X minus 1, that means 4X plus 1. Now 4X plus 1 is our what? Generalization of finding matchstick in any number of trapezium. Now in this expression, in any of that expression there are two main components. One is our variable and another is our what? Constant. Now a variable has various values while a constant has fixed value. We combine variable and constant to make algebraic expressions. For this we use operations of addition, subtraction, multiplication and division. Now look how the following patterns are obtained. This expression is obtained by multiplying the variable x by itself. So it is x square. We can also write as 6 square. Now similarly in this expression it is obtained from 4 into y. This expression, firstly we will multiply it by xy to get 2xy and then we will add 7 to it, so it becomes 2xy plus 7. So from the above statement, these are our what? Algebraic expressions. Hence an algebraic expression is an expression in which variable and constant are combined with the symbol fundamental operations, that is plus, minus, multiplication, addition and division. Now this is our another algebraic expression and these are our what? These are the terms, and each term is separated by the algebraic expressions plus and minus. So a term should contain a constant, a variable or unknown, a product of a constant and an unknown number like 6xy, 7xy, 7x square, a product of 2 or more unknown numbers like x square y and so on. Now next is our examples. Here are our examples of algebraic expressions, and here are the 3 terms and here are the respective 3 terms in this expression. So here we have to fill this following table. The constant will be 4, the coefficient will be here it's 17 and minus 6, number of terms are 3, highest power of a variable is 2. That's how you have to complete it. Now next is our types of algebraic expression. Now depending on the number of terms, algebraic expressions are classified as monomial. That means that contains only one term, that is 30x, 5 and 7xy. Binomial, that contains 2 terms, that means 2x plus 3x square plus y square and so on. Trinomial, that contains 3 terms, that means this one contains 3 terms, 1, 2, 3, 3 terms. Polynomial, an algebraic expression that contains 2 or more than 2 terms, that is our polynomial. For example, 1, 2, 3, 4, it's a polynomial. 1, 2, 3, 4, it's a polynomial. Now next is our constant, coefficient and powers. Now to understand constant, coefficient and power, let us consider this expression. Now in this expression it has 3 terms, these are our respective terms, and in this term minus 8 is what? Our numerical, which is multiplied to a variable a square, and it is also called the coefficient of a square. Here are the power of a is 2. Now in 14a the coefficient is 14 and the power of variable of a is 1, and the third term 4 does not have any variable multiplied to it and is called the constant term. Here is our example. We have to write the coefficient of x in each of the following. So here the coefficient of x is minus 6, coefficient of 5x 5, coefficient of ax plus 7 is a, and here the coefficient is 7a. Now hence, in a term of algebraic expression, any of the factors along with the sign is called the coefficient of the remaining factors. Now let's look at the like and unlike terms. First one is our like terms, that means the terms which have same literal numbers or variables with the same degree. For example, here x, 3x and 8x are our like terms because they have same variable x. Here they are like terms because they have same variable, that is x square y. Next is our unlike terms, that means which have different variable parts. Here the first one is 3x and 3y, unlike terms. 5xy, 7x and 8y, also unlike terms. Next is our degree of an algebraic expression. Now the degree of an algebraic expressions depend upon the power of variable present in it. Now algebraic expression can be in one variable or two variables or more. First is consider one variable x. Let us take an algebraic expression. This is our algebraic expression. It has three terms. These are the three terms. In 5x cube, power of variable is x is 3, so the degree is 3. In 6s, the power of variable x is 1, so the degree of 6x is 1. In term 8, it has no variable, so that means the power of variable is 0 and the degree of 8 is 0. So what we can conclude? We can conclude that the degree of algebraic expression is the highest power of the variable in that expression. Now the degree of expression here is 3. Now consider another example. Here we have two variables x and y. Now in this expression, the degree is considered as 5. When the variables are multiplied, then the powers are added to decide the degree of the term. So here this term has degree 3 and 5xy has our degree 2 and 8 has 0 degree. So the highest power of variable in this term is our 5. Hence the degree of expression is 5. Here's our example number 2. Here we have to find the degree of the following polynomials. First we will write the polynomial in descending order of powers of their terms. In the first one the degree is 4, second one the degree is 3, and in the third one the degree is 7. Here we have to find the value if x and a value are given. So we are substituting the value of x and a, and here the value after putting all the digits is 25. Now let's start with exercise 5.1. In the first one, here we have to write the numerical coefficient of each term. In the first one, the numerical coefficient is very good, that is 8. That's how you have to complete the remaining ones. Next is our addition of algebraic expressions. The basic principle of addition is that we can add like terms only. Unlike terms cannot be added. So to add two or more algebraic expressions, we collect different groups of like terms and the coefficient of like terms. Now we can do it by two methods. First is our horizontal and second is column method. Let's start with the horizontal method. Now in any method of addition, we arrange all the terms in a horizontal line and then we add by combining the like terms. Example, here we have to find the sum of all these, it's 14x. Here we have to add these terms. So firstly we will add the x ones, then the y, and then the constant. So this is our expression. Again here we have to add these terms. So firstly we put all the same variables together and after that we will add, and the algebraic expression is minus 5x square minus 11xy plus y square. Next is our column method. In this method we add like terms in column and then add them. Here's our example number 7. Here we have to add the digits. So we are putting them in the column and the answer is 8a minus 2b plus c. Again in example number 8 we have to add these column wise. So we put all the equivalent terms in the column and then we are adding. So it is minus 5x square minus 11xy plus y square. In example number 9, here we have given the value of p and q and we have to find p plus 2q. Here is our 2q. We multiply q by twice and p plus 2q is 5x minus y plus 7z. Now let's look at the subtraction of algebraic expressions. Like addition, subtraction is also possible between two like terms only. So whenever we subtract a number from another number, we add the additive inverse of that number. For example, here we have to subtract 2 from 6. That means we will change the sign of 2 to negative. So it becomes 6 minus 2, that is 4. Now subtraction can be done either in column or horizontally by combining the like terms after changing the signs. Here is our example number 10. Here we have to subtract these terms. So firstly, what we will do, we will subtract these terms. Now after subtracting these, the answer we get is minus 13a plus 10b. Now here's our example number 11. Here we have to subtract this term from second one. So in the column method, a cube get cancelled. It becomes 2b cube and this is also cancelled. So minus 2b cube is our answer. Example number 12. Here we have to subtract this term from the another one. So firstly we put them in the similar column, then we are changing the sign, plus to minus, minus, plus to minus, minus to plus, and after that this is our required algebraic expression. Here's our exercise 5.2. In the first one, we have to pick the like terms from each group and add them. So the like term in these groups are 5b and 7b, and when we add 7b plus 5b, that is equals to 12b. That's how you have to complete the remaining ones. How much larger is this number than this one? So what we will do, we will subtract. This is 13x square minus 6x square, so it will become very good, that is 7x square, and minus 7 plus 9, that is plus 2y square. That's how you can complete the remaining ones. Next is our chapter end exercise. Here we have to take the correct option. In the first one, the terms of the expressions are 3x square minus 5xy, 7x square y square, and minus 7. So C option is our correct answer. That's how you can solve the remaining ones. Next is our mental maths. Here we have asked that one sided of equilateral triangle is 3a plus 4b meters. Find its perimeter. So what we will do, we will multiply it by 3, or we can add these 3. That's how you can find it. Here is assertion and reasoning questions that you have to solve it by yourself, students. Now I hope you have understood the chapter pretty well. You just have to practice exercise questions and don't forget to revise this topic again.